Hello, everyone, from wherever you're joining us from. Good morning, good afternoon, and good evening. I'm very happy to have all of you here today. My name is Dalia, and I work as a Senior Developer Marketing Manager here at Kong. We have Deepak here with us and Marino. They're both going to run the two workshops that we have prepared for you today. The first workshop will be the Automating Kubernetes Ingress Management with Kong Gateway Operator, and Deepak will deliver it. I will let him introduce himself to you and tell you a little bit more about what he does here at Kong. And then Marino will take over the second workshop, which will start in about an hour. So the sessions are being recorded. You will have access to the recordings after that. We will send you a follow-up email. We will also upload them to the YouTube channel that we have. I will send you the link here in the chat. Please put all of your questions in the Q&A function, which is on the bottom, instead of the chat, so we can then keep track of the questions. And if you have any technical issues or any other comments, please put them in the chat. So with that, Deepak, please take it away from here.
Yes, thanks, Dalia, and welcome everyone. I'm Deepak Grewal. I'm a staff solutions engineer with Kong. I've been with Kong for more than 3 years now. I am based out of the Netherlands, and I work primarily with the customers around this region, who are using Kong API gateways and Kong Ingress controllers. So nice to lead this webinar and show you how we can automate Ingress management with Kong's gateway operator. The agenda for my workshop, the first one is this. I want to tell you a little bit about the Kong architecture and deployment approaches, and how we can deploy Kong in Kubernetes. I want to talk about a little bit about the Ingress versus the Gateway API, which is a new form of managing routing into your Kubernetes clusters. And then I want to talk about the Kong gateway operator. How do we deploy gateways using this operator? And there's different architectures you can use. You can have a central gateway where all teams within the cluster share the gateway. There's architecture where each team deploys its own gateway, where you can have internal versus external gateways. So we'll talk about how we can do that within Kubernetes. We will also talk about how we do upgrades of those gateways using that Kong gateway operator, how it manages that. We'll also talk about scaling those gateways. So think about, once you've deployed an API gateway in your cluster and there's a spike in traffic, how does that scaling option happens? And we'll try to do all of this live, not just slideware. So let's see how it goes. If things break, we'll try and fix them. But a little bit about Kong. If you were not familiar, we are an API platform company. We're one of the leading API platform companies. You can see some of these figures on the screen. We're also a leader in the Gartner API management. We have over 800 enterprise customers now. So we work a lot in both the Benelux as well as the European region with a lot of our customers. Kong Connect, I want to talk about this as well. Kong Connect is our SaaS-based management plane. So again, we host it for our customers, and you can connect your runtimes, and those runtimes could be Kong gateways. Those could be Kong Ingress controllers in Kubernetes. They could be a service mesh, or they could be the AI gateway, where you could deploy these gateways in your own clusters, in your own premise, but they can connect to this management plane where you can actually monitor and manage those gateways. In a Kubernetes environment, there's really two ways of deploying Kong gateways. And the two ways are either a hybrid approach or what we call a DB-less mode. So in a hybrid approach, you would deploy a Kong gateway as a standalone service as a standalone application within the Kubernetes cluster. And that can be managed using this SaaS control plane that I was talking about, which is Kong Connect. The other way of deploying Kong gateways on Kubernetes is what we call the DB-less mode, where you would deploy Ingress controller as well, which then sort of spawns a Kong gateway, and all the configuration is then natively managed in a Kubernetes way. So all the configuration stored in a Kubernetes API server. You still have our managed control plane for things like analytics, but you would manage that Kong gateway using Ingress resources. So those are the two main ways of deploying Kong's API gateway within Kubernetes. If we think about the Kong Ingress controller, what it does is it allows you to run Kong gateways on your Kubernetes clusters. And the way you manage that Kong gateway is through these Ingress definitions or Ingress resources. Now, we've also, from day one, also supported the Gateway API resources. But before I talk about Gateway API versus Ingress, I wanted to first level set with you on what Ingress is. I'm pretty sure all of you know, but Ingress is a resource you create within your clusters. It helps you route HTTP requests to the right service. So you have a Ingress resource defined. You define certain paths that allow connections to come in, and you put in an Ingress class. In this case, it would be Kong. But there are some limitations to this Ingress. And the first one is who manages this Ingress resource. So if you think about it, there is a platform team or an infrastructure team that deploys and manages Kubernetes clusters, could manage, gateways that are being deployed on them, like Kong. And then there's application developers who are deploying their services within those clusters. But this Ingress resource is all of these objects in one sort of file. So it becomes, a bit of a challenge on who manages this. The other limitations of Ingress are that it only offers basic routing, so host, path-based routing. There's no route by headers by default. There's no route by parameters. Of course, those specific Ingress controllers could, route in a more complex way, but natively Ingress has these limitations. There's other limitations, of course, as well. And that's where the Gateway API comes in. So it's a new way of managing level 4, level 7 type routing within Ingress. And it sort of divides up or breaks up the Ingress resource into 3 main resources. So that initial resource can be divided up into, say, a gateway class and a gateway, which again, recommended way is that the infrastructure providers, so the cluster operators and the cluster managers would manage the gateway class and gateway, and then the application developers would manage the actual underlying routing within those clusters. And so that's what the Gateway API is. It sort of is the evolution of Ingress. And Kong has been at the forefront of this. We've supported Gateway API from day one. Like I said, we are also actively involved in the SIG committee for this Gateway API. If I just zoom into the Gateway class and the Gateway resource, what they are, Gateway class is like a template, a blueprint of a gateway. So this is what it looks like. And then the gateway itself is an instance of that class. So if you've come from, object-oriented programming, you're sort of defining the class, and then you're instantiating that class using the gateway. And so here you can see I have a gateway class. It's using the gateway operator as the controller name. And then I instantiate that class using this gateway resource, and I define the listeners that this particular gateway listens on port 80. This, by the way, is also one of the limitations of Ingress, where, to define where that gateway or where that Ingress controller listens on, it's part of the, it's almost, buried into how the Ingress controller is installed. Whereas in this way, you can actually see which listeners there are on a gateway, and it's easy to configure. The gateway class name, this is how they're linked, of course. So once you create a type of gateway class or a blueprint, you can instantiate it by providing it the same class name. Once a gateway has been provisioned within a cluster, you can have this concept of shared versus non-shared gateways. So each gateway, apart from the ports that it listens on, also has this additional parameters called allowed routes. So this defines if the gateway that you provision within your cluster, does it listen on routes from all namespaces, or does it only listen to routes from a particular namespace? So here, again, there's two examples here. So on the left-hand side, I have this shared gateway. I've deployed it in a namespace called shared gateway. And in terms of the routes that it's listening on, it's listening to routes from all namespaces. So regardless, there might be a cluster with 5 or 6 different namespaces, each for one different team, for example. And whoever defines a route within those namespaces, this gateway can listen for that and actually share that on this port. But you can also have these specific gateways. So think of internal versus external traffic. So you might have an internal gateway versus an external gateway in the cluster. And here, then you can scope out, which routes is it listening to. So here this is a team-based gateway. So the namespace is team front end. Let's say they've deployed their own gateway, and it's only listening to the routes from that particular namespace. The way routes are defined are using, again, another resource called HTTP route. So routes are generally are scoped to a particular namespace. However, they can point to a gateway in another namespace, like I was showing earlier. So for example, this particular example is of a shared gateway. So I've deployed the shared gateway, and within one of my namespaces, I define a route called /service1, and I point in the parents ref, I pointed to that shared gateway. So this is how you would define routes on a shared gateway. You point it to that particular namespace. Going back to this picture, our Ingress controller, the Kong's Ingress control can be configured to listen for both type of definitions, either Ingress or Gateway API, the one that I just showed you examples of. So both of those are supported by Kong's Ingress controller. And then let's talk about the Kong gateway operator. So Kong gateway operator is a way to manage your Kong gateways using custom CRDs, and it automates the deployment, scaling, and the configuration of those Kong gateways inside Kubernetes. And again, I'll show you examples on how Kong operator does this. So I think it's probably a good time to now switch over to some demos. So the first thing I'm going to show you is a deployment in a Kubernetes cluster where we're deploying a shared gateway. There are 3 namespaces representing namespaces for different teams. So we have a team data, team front end, team platform. They each have their own services deployed. And then we have a shared gateway deployed here. And all of these, so again, the thinking behind this is that the infrastructure operator or the cluster managers would deploy the central gateway, would manage the central gateway, and then the respective teams would just be defining their own routes. Again, this is using the gateway API structure. So let me see if the demo gods are with me today. So I have a Kubernetes cluster running in K3D. And let me go to one of my directories. And before I do anything, actually, I'll run this script to get the gateway operator installed on my cluster. You'll see some pods coming on board. So we have the Kong gateway operator being installed. And then it goes on and the script does a number of things. It goes on and creates some namespaces for the different teams, team backend, team data, team frontend. It also goes on and creates services. And let me show you what that shared gateway looks like. So this is what it's running. This is the example I showed you before. So first I used a gateway class. Again, that's a blueprint for my gateway. It doesn't actually instantiate the great gateway, but then this is the actual resource that actually starts up or an actual gateway in my cluster. And of course, I reference the gateway class Kong. It's listening on port 80, but the way I've configured the ports here are that port 8000 points to port 80 in my cluster. And let me see, it's going in and instantiating everything. And what I could do is go to my shared gateway. I can see that it's running. So if I went to HTTP localhost port 8000, when I do go to HTTP port, localhost port 8000, this actually points to my gateway. You can see even though I'm getting a 404, this is actually coming from the Kong gateway within my cluster. It's just saying, well, I received this request, but I don't know where to route it. And so it says no route matched. Now what I can do is go in and create some routes. So again, think of me as a developer working for team data, and I'm going and creating these routes. I have 2 services called Data Service 1, Data Service 2. They're part of my namespace, both Data Service 1 and Data Service 2. But now I want to expose these onto this shared gateway. So again, when I apply this resource on my cluster, it's going to point to the shared gateway. So I can go in and apply this this route. So that route gets created. So now when I go to my localhost / data service 1, I actually get HTTP 200 OK hello from data service 1 because it's basically taking this path, it's directing it to another service called data service 1 that's listening in my cluster. And all that is doing is echoing back what I'm sending it. Same thing for data service 2 should also work. Hello from data service 2. So essentially, and by the way, because this setup takes a long time, before I move on to my other example of multiple gateways, let me start that up already. Multi-tenant. Actually, let me first uninstall. Let's see. Let's go to multi-tenant. And again, I'm just running the script beforehand because I know it takes a bit of time to set up. But anyway, coming back to this. So this is sort of the example we've seen where we have a shared gateway. But we can go into other type of architectures here. So this is another form of architecture where you could have an internal gateway versus an external gateway. Think of internal gateways as basically serving internal services. It's not exposed to the internet. And external gateway is exposing services to the outside world. And they both might have different policies. They might be living in different namespaces and things like that. And again, they might be listening to different namespaces when you are creating these routes. But the other structure, again, another structure is where you let the individual teams manage their own gateways. So again, we take the same, architecture where you have a team data, team front end, and a team back end, and you let the teams instantiate their own gateways so that they're completely isolated. They can manage their own versioning of those gateways. They can manage their own type of gateways that they're installing. It doesn't always have to be Kong. One team could be installing Nginx, one team could be installing Kong. But of course, yeah. So those are different ways, but this is for this structure. Let me see if my scripts finish. It takes a little bit of time to set all of these up. So what it does is, again, it goes in and creates different namespaces. Let me see if it has done it. So it creates all these namespaces, and within each namespace, we can go in and create different gateways. So currently it's creating a gateway. You can see how in the team backend, it's just waiting for that gateway to be ready. And again, it takes a few minutes. I can see it now running. And then it will go in and, okay, so all gateways are now running. Let me show you what that configuration looks like. So in a multi-tenant environment, for example, team front end would have their own gateway class and the type of gateway. So again, team front end now has a gateway that's listening on a different port, for example, port 8002. And there might be a team data which has a different gateway listening on port 8001. And same with team backend. they might have their gateway listening on port 8003. So within my cluster, all of these are accessible. So 8001, again, it's this is one of the Kong gateways that's running within the cluster. It's it replies with 404 not found. 8002 should also work. So should 8003. So those are three different gateways now running within my cluster. Now team data again would go in and define HTTP routes, but this time instead of using let me make this bigger. Instead of using a shared gateway, they're now pointing to the same namespace as where they've deployed their services, because that's where their gateway is now running. So I can go in and let's see, I think I would have applied the routes here. So if I'm running on 8001 slash data service, yeah, so this works. Again, that's because of the route that we have defined there, and data service 2 should work as well. Same for backend. So the backend is running on 8003, and I can look at the routes for the team backend, which are backend service 1, backend service 2. And again, these routes are scoped to a namespace, of course, but I'm also pointing the parent ref that these where my gateway is actually running. So this is where the gateway runs. And let me look at the port one more time, 8003. So if I went to HTTP localhost 8003 slash backend service 1, so I do get a valid response here. So this is how, I mean, this is basically the setup that I'm describing, that we've done it in this diagram, where each team is managing their own gateway. This is not the only way, by the way, of managing Kong gateways within the cluster. As I said to you before, there are two ways of managing Kong. So the way that I've showed you just now is what is known as the DB-less mode, where we have a Kong operator which is deploying an Ingress controller and a data plane within your cluster, within your Kubernetes cluster, and all the information, all the config is being stored in the Kubernetes API server. But we can go to this hybrid mode as well, where you deploy your Kong gateway, again using the gateway operator, but it connects to the control plane, which is in Kong Connect, which is our SaaS environment. So we can look at an example of doing that as well. So let me go in here and let me do reinitialize my cluster for a second. Actually delete the cluster and reinitialize it, because I do want to show you updates as well as scaling for the gateways. So once that cluster is up, let me go to namespaces is fine. And here, okay. And let me see. Yes. So I'll go in and install, and I'll explain what this script is doing, by the way. So I'm running a new script on my cluster. What it's doing is it's first installing a Kong gateway operator. but this time it's installing my gateways in a hybrid mode, which means it's gonna connect to my SaaS management plane. And my SaaS management plane looks like this. Again, we don't have time now to go through all the features of our SaaS-based management plane, but just know that this management plane is quite powerful. Again, it gives you the ability to segregate different environments, different teams. It allows you to have developer portals. It allows you to document all your APIs within one catalog called service catalog. It allows you to have analytics and some tracing. So there's lots of functionality in build. We don't have time to go through all of it. But what I do want to look at this. So this is my two of my data planes, which are running in my cluster that I just initialized. So you can see that they just connected to my management plane, and they have the version 3.9.1. And why are there two of them? So let me show you now the configuration for this. And these are the scripts I ran. So we have a resource called data plane. Again, this is part of the CRDs that got installed with the gateway operator. And we define certain extensions. Again, not really important as to go through all of these CRDs, but this is basically defining where this data plane connects to. I define an image of my gateway that runs. And I also define some scaling options. So again, here I've defined that minimum replicas has to be 2. And that's why you actually see those 2 instances connecting to my control plane. And maximum is 10. And again, I define some behavior on when it will scale up and scale down. It looks at average utilization. As soon as it exceeds 50, it's going to start scaling up those replicas, and we'll run a test here pretty soon on how it does it. Same for scaling down. Of course, these numbers are just for demo. You would probably have bigger numbers in production here. And but before we go into scaling up and scaling down, first let me talk about how you would go in and upgrade these gateways. So again, I have a version 3.9 of my gateway running in my cluster. To upgrade that, I would basically change this image version to 3.10, for example, and that should upgrade that gateway. This is again the same configuration. All I've changed is done a new version of the gateway, which is 3.10. And if I were to go in and apply this new version, so kapply data plane upgrade, you will see within my cluster, it starts a rolling upgrade. So it's not provisioned 2 pods straight away. It's only provisioned 1 of them. And while it's getting ready, it takes about 40 seconds or so to be in a ready state. I can go into my management plane as well, and hopefully this should show me those things. So here you can see now I have a 3.10 in parallel with 3.9. And then within my cluster, the other 3.9 will shut down and 3.10 will start up. So now again, you can see 3.10 is starting up, and eventually that 3.9 version will completely be shut down. Again, the users that are using this gateway within that cluster won't experience any downtime when these rolling upgrades are happening. So that's one way. We can also now test out the scaling within this cluster. So we can have a look at, I'll use K6 to run some load. And again, on my cluster on the left, you'll start seeing as that load ramps up, you'll start seeing extra gateways, extra data planes being created. So we'll give it a few seconds here. Let me see if I can show you the data plane. So at the top, you can see the horizontal pod autoscaler, the CPU versus what the target is, and the minimum and maximum. And also you can see how the replicas are scaling up in response to the load that I'm generating within the cluster. So we're up to 7. It will go up to 10, and now it's up to 10. Within my management plane, I can also see that. I'll refresh this. You can see we have now 10 different replicas, all trying to serve a spike in traffic. And then as the load goes down, it will start scaling down. So now that K6 script has stopped, and then it should, once it detects it, it will start scaling down those replicas that it created. Let's see. Yeah, so here you can see now it's started terminating those. Yeah, and eventually it will go back to 2. I'll refresh this page. So yeah, we're back to 4 here, and eventually, yeah, it will go back to that minimum number of pods that I had, which was 2. All right, so that's sort of what I actually wanted to cover today. We've talked about rolling upgrades. We've also talked about auto scaling, which can be defined with the Kong gateway operator, which uses the horizontal pod scaler to drive this behavior. There are other scaling approaches. If you went to our website on how you could scale your underlying services, for example, based on latency that the gateway is seeing, because remember, the gateway is exposing your services within the cluster. So we keep track of things like latency, things like errors coming back from your services. And then based on that, you can also scale your workloads. So not the gateway, but the actual workloads based on those figures. And we have a guide on our docs site on how to do that. It's basically by creating your own metrics within the Kubernetes and using those to auto scale your workloads. I think that was it. And I know yeah.
Thank you, Deepak. This is the end of the presentation?
Yes, this
Yeah.
is This is the end, yes.
Amazing. Thank you so much. And now we have some questions in the Q&A function. If you want to take a look,
Yeah.
let me open them.
Yes, so how can we define host name based routing? So for all requests to be handled by a certain gateway. Yeah, that's a good one. I don't remember where you specify those. I believe it's in the HTTP routes. You specify those, but again, don't quote me on it. So again, this is something specific to the how you create those resources within your Kubernetes cluster. Yeah.
Let's go over the Q&A function and not the chat, because then we can keep track of the questions. Do you see the Q&A on the bottom? Not the
Oh,
chat.
okay. No, I don't. Let me see.
It's on the bottom. No?
Let me see if I can find the Q&A button. No, I don't.
Okay. Yeah, it's down there. Chat, raise hand, share, Q&A. If you want, stop sharing maybe, and then you will see it.
Okay, let me try that. Okay. Sorry, guys. Yeah, Q&A. Okay. Yes, does Kong support UDP traffic? Yeah, we support TCP as well as HTTP. UDP, I'm not sure actually on this, and so I don't want to give a wrong answer. We'll have to come back on this. Why is it called K9S? That's not our tool. That is just a load testing tool by someone else. Sorry, not load testing. That's just what do you call it? A visualization tool. That's why it's called K. I don't know why it's called K9S. Again, the host name based routing, yes, you can define it. I just don't know the right, I don't have an example of that for you. So yeah, it can be done. Can I work with custom plugins on Kubernetes Ingress Gateway the same way we use them on Docker? Yes, absolutely. Plugins are defined as CRDs, and maybe I do have an example. Give me 1 second. Let me see if I have an example of it. No, I don't have an example of it, but if you were to search for Kong plugin, that's one of the CRDs that gets installed. And yes, you can define plugins on a Kubernetes Ingress gateway by applying these CRDs. So another question is, how does Kong compare to Apigee? So that's a very broad question. How does it compare to Apigee? I can give you sort of the main highlights here. Apigee from Google is, I guess, very, pro Google, whereas Kong can be installed on multiple clouds, on-prem, on Kubernetes clusters. It's the same sort of binary with the same functionality that's installed everywhere. That's one of the big differences. The other differences I'd say is our API ops approach. Again, that's something that we haven't seen today, but all the configuration for Kong can be defined in YAML format. So I'm not talking configuration of the gateway or deploying the gateway, but actually configuring it, not just in a Kubernetes cluster, but let's say running it on virtual machines, things like that. So they can all be configured as code, which makes it easier to automate everything. And again, maybe Apigee has similar automation in place, but from what we hear, it's a lot easier with Kong. So again, very broad question, but I have to say automation and architectural flexibility are the two main things, is what I would say. Is there support for service auto discovery? Yes, so we have introduced what we call the service catalog within our Kong management plane, the Kong Connect that you saw, where you can link things like GitHub repos, where you can link things like PagerDuty, where you can then it will automatically discover services within those sources. So we have a lot of extensions that are there, which will automatically discover those services. How does it differ from Istio Gateway and why you should use Kong?
Hey,
And
Deepak, can I take that one?
yes, of course, yeah.
Awesome. So, hey, everyone. Having spent some time working with both the Istio Gateway and Kong Gateway, what I can tell you is Istio's Gateway is specific to its service mesh technology, and it doesn't operate as a full-fledged API gateway as well. So what that means is if you're looking to do additional capabilities like rate limit capabilities, or you're looking to implement some sort of authentication logic as well, that's offered through the Kong gateway through a variety of plugins that are available, and that gateway itself is extensible. And in addition to that, what you can do is you can use the different CRs or custom resource definitions when you're operating inside of Kubernetes to effectively configure these bits, treat it like an API gateway, but make it much more Kubernetes native while still taking advantage of the gateway API functionality as well. That is the current standard for doing Ingress capabilities. So from a different standpoint, the Kong gateway itself is very flexible. It can be deployed to any kind of environment, whether it's a virtual machine-based environment, EC2, whether you're running inside of containers, whether you're running in Kubernetes, whereas the Istio gateway itself is specific to just Kubernetes and isn't even a full-fledged API gateway.
Yes.
Then we have two more.
Yeah, route by parameter. Again, yes, we can route it by modifying the HTTP route. Again, I would point you to the Kubernetes docs, where they have an example on how you can route by parameters. And update strategy if the setup or the data plane is running on a virtual machine. It depends on what type of virtual machine it is, but generally speaking, what you would do is you would have Kong gateways behind multiple instances of Kong gateways behind a load balancer. And by the way, the load balancer could itself be Kong, and then you would be doing those rolling updates either manually or if the virtual machine supported it automatically. So again, it's not something Kong provides out of the box. In a Kubernetes world, the horizontal pod scaler does that for you. That's for the loads, but in the Kubernetes cluster itself does the rolling updates for you. But on a VM, you would have to do them manually. But the main point is you could have multiple instances of Kong running and just upgrade them one by one on a VM without any downtime, which is again one of the big advantages of Kong. Because these gateways are so lightweight, you can run them multiple instances. I see another question around BG deployment.
That's blue-green deployment.
Oh yeah. Yes. So again, we haven't seen an example of it, but again, because of lack of time, really. But you can do blue-green deployments of the Kong gateway in Ingress in the Kubernetes clusters. We have a documented example of this in our, again, docs page. Yeah, we can do that.
Okay, any last questions for Deepak and Marino? And then we'll take a break and we'll start with the second workshop. But any last questions, please post them now. And then we'll wrap up the first workshop. Let's see. No. All right. Well, Deepak, thank you so much. Really appreciate you running our first workshop. Thank you everyone for joining. We'll take a 7-minute break, after which we're going to start with the next workshop. Don't leave this link. We'll just, mute the workshop for now. And then in 7 minutes, we'll get started again.
Thanks, everyone.
Okay, let's get going with the second workshop. I'm going to stop sharing my screen and then Marina, you can take over.
For sure. All right. Thank you so much, Talia. And hello, everyone. Feel free to let us know where you're dialing in from. I'm currently in London. Um, the KubeCon event, KubeCon EU, is currently going on, and it's day zero at the moment. So I did my session that I had to present around open telemetry and had to run back to my hotel room because it is extremely difficult to find a good location to sit down without being distracted by all the walking people. And at the same time, the Wi-Fi is not that great, other than here being at my hotel room. So I wanted to give you all some stability with how I'm going to present. And yeah, I will get right into it. Let me just share my screen. 1 second here. Hopefully y'all can see that. Dahlia,
Yes.
let me know if, okay,
Yep, all good.
perfect. I'll just maximize this. Okay, welcome everyone. So feel free to go ahead and scan that QR code, and that'll take you to a very similar environment that I'm working off of. And you can feel free to follow along and take the exact same lab with me while I'm doing this, or feel free to take this when you are available to do so and just watch me do my thing. But my name is Marino Wijay. I am a staff solutions architect here at Kong. So I work under the professional services organization, and I spend a lot of time doing a lot of implementation work, design work around a lot of our Kong technology and the extended ecosystem that Kong ties into. You can find me on the Blue Skies or on that Bird app if you're interested. So let's just briefly set the stage around these large language models because I'm sure a lot of you are using them today. You're probably using something like ChatGPT or some other tools like Perplexity or even Claude to conduct some of your activities to help you develop some code, uh, a variety of things, right? You can think almost anything. But backing these front ends are large language models that effectively are trained on a variety of very large data sets. Now, these data sets can be pretty recent, they can be pretty aged, they could be very specific to language models, like specifically a programming language, perhaps Rust, perhaps C Sharp, maybe Java, JavaScript, TypeScript, whatever it is. Maybe some of these models are trained on current data, current climate data, if you will. Some of these models might be trained on a variety of other systems, like how Terraform works or how AWS works. Now, the idea here, though, is you will consume this model and send out your query or your prompt, and you'll get a response back, something that's fairly accurate, mostly accurate, and then you'll just do your own validations. But we're not just doing this once, we're doing this multiple times. In fact, we might be collaborating across different teams to do this multiple times over, and you might have members on your teams that ask the same thing at times. And sometimes that, while it's great, it could cause other challenges for you from a cost perspective, from a performance perspective as well. So Kong's here to help. We have a number of different capabilities that really assist with the way you consume these models. You might have multiple models that you're consuming locally on in your environment, in your, let's say your data center environment you built out, let's say some GPU, private data centers, and you're running those models there. You might be consuming a little bit of those cloud-based models as well. But you need a way to tie all of these systems together and make them a little bit more resilient for you and your business usage. So there's a few key plugin capabilities that we've launched and enabled in the last few years. Now, think of the Kong gateway for a second. We just saw how the Kong gateway operates in Kubernetes with the Kong gateway operator. Pretty cool stuff. That same ideology transfers to what I'm going to talk to you about today. Whether you're running your gateway in Kubernetes, whether you're running your gateway as a VM, or you're running it in the cloud, or as an ECS container or service, it doesn't matter. At the end of the day, it can still do these same AI gateway functions. Now let's briefly talk about each one of these, and then we're going to jump right into this lab environment. So we have something called the AI proxy. And the AI proxy here is allowing you to effectively proxy your LLM prompts through a Kong gateway. So you'll plug in a model endpoint, and then you'll feed in your requests, your prompts through that proxy. Pretty straightforward, pretty standard. But then we want to get a little bit more advanced. Perhaps we want to guard the kinds of prompts we send over to our model. Maybe we want to ensure that we don't send dangerous types of prompts that could generate some really bad code, and we want to protect ourselves from that. Maybe we want to avoid using a certain type of development language because it doesn't align with what we do in our code base today. And so we'll use something like a prompt guard. Maybe, a lot of the developers don't have all the correct prompts in place. And so sometimes we have to decorate that prompt a little bit so that there's some additional context added to that prompt that's sent over across the wire over to the model and through the gateway. Now, there's also a few other plugins that we take advantage of. The response transformer, which essentially takes that model's response when it's about to send it back to you and effectively modify it in such a way so it fits maybe a particular set of guidelines or a policy that you have within your organization. And the same would happen for a request transformer plugin as well. I'm sending a request out to a model. Let's transform it a little bit so the model itself can interpret what our request is. Maybe we're just not sending it in the right format, and that's our option to, on certain matches, make sure that that request is transformed appropriately so the model can interpret it and provide an appropriate response back to us. We might be at a point where we're consuming all of these models, and you might have heard this concept of tokens that are being consumed, and there's a variety of ways to interpret how these tokens look and what prompt would make up a set of tokens or how many tokens we actually consume. But we might want to be a little bit more cautious about how much we consume. Perhaps we want to put a rate limit or apply some sort of quota to effectively ensure that we don't overutilize how many credits we have available to consume that model. Maybe we have a situation where we're limited in budget, so we'll use as much local modeling as we can. We can use maybe something like a Llama 3 or something similar locally. And then when we actually have to get something a little bit more intelligent, something that requires more reasoning, then we might send it up to a more advanced model, but we have limits and we have to put that in place. So that rate limiting advanced plugin pretty much similarly mimics what we do for our regular request rate limiting when we have a variety of different conditions. We'll also offer up developers a prompt template that effectively enables them to send their prompts in a very templated fashion. So they don't have to think deeply about what their prompt actually needs to look like. They can just create a very simplistic prompt and then align it to the template that's already present, and then that gets shipped off to the model. Then we have a few more advanced plugins, the Proxy Advanced, which might enables us to do a few things. Like we have a situation where, like I was talking about previously, we have a lower class model that's on-prem and we have a more expensive model that lives in the cloud. And we have a situation where our local model is going through some maintenance and we need to upgrade it to the latest version, thus making it unavailable for a certain period of time. And we'll then proceed to load balance to an advanced model. We'll send our traffic up to a much more advanced model and effectively get the necessary responses that we need. Perhaps we have different kinds of prompts that we're sending. Some of the more common questions that we'll get or the common prompts that we'll send off to a model, let's keep it local. Or we might even send it to a lower cost model in the cloud, while some of our more reasoned or deeper thought prompts out there will be sent out to the advanced model. So as an example, maybe for everyday tasks, I'll use GPT, 4.0, and then for some of that additional reasoning, I'll use O1. And O1, as we know, is expensive. It takes a little bit more time. But we also have to consider something around latency as well, because if our applications are latency sensitive, we have to be able to mitigate some of that somehow. Every time we have to send out a request to a model, it takes time. It takes time to get a response back, especially if we're having it reason a little bit more, having it think deeply about what we're trying to ask and provide a more thought out or full-on answer, maybe a more complete answer. So in those circumstances, we'll use something like caching. Now, you might use a vector database to handle that caching for you. And what will happen is similar requests for that matter, when they make it through to a gateway, the gateway and its vector DB do an evaluation of that request. And if for whatever reason they seem to be very similar, that's a cache hit and effectively translates to that model just simply not being hit at all. The request doesn't even go all the way to the model. We'll just return a cached response. Now, we might want to provide some more context around some of the requests and prompts that we send out, and we might want to even provide some more firewall-like guards. So we have a semantic prompt guard that effectively locks down the prompts to be a little bit more specific with additional context. And that could be something as deep as, I want you to tell me about like all the Kong technology, but I don't want to know about open source. I just want to know specific enterprise offerings. And you might just prevent yourself from going down the open source path or even open source configuration only because that doesn't comply with your policies and guidelines within the organization. So that's a brief of all of these different plugins. We've got plenty of presentations that dive into the depth of them. If you're interested, you can always take a look. We're going to go ahead and take a look at our lab, and we're going to have to hop around a little bit between Connect and our lab environment. And when you're going through this lab, you'll probably find that you may need to create a Connect account. And if you're having to create a Connect account, it's because you're going to have us host your global control plane, your gateway control plane. And that means you don't have to worry about deploying it locally. You don't have to worry about life cycling it. All you need to consider is deploying a cloud gateway or deploying a gateway locally or in your data center or in your cloud environment. And we even offer up the option to do a cloud gateway that's hosted by us too, a data plane that's hosted by us so that you don't even have to manage that and even have those infrastructure concerns or considerations. So let's go ahead and get started. And as we're going through this environment, I'll definitely explain to you how things are going and what we're actually doing here. So in my little terminal here, and hopefully you can see this, I'll make this a little bit smaller so that we can see the terminal a little bit more. We're going to go ahead and run through deploying a Kong gateway. Now I've gone ahead and already provisioned myself a Connect environment, so you can definitely go do that if you want to, or just follow along here. And what we're going to do, I'm not going to really touch this or talk about this stuff because I kind of already hit the high level. What we're going to do is we're actually going to create a gateway control plane. So I've gone through all of this process. I already have a Connect account. You can do this in probably about 5 minutes if you want to, but we're going to go right into the gateway deployment here. So I have a serverless gateway here. I'm not really going to use it, but we're actually going to go in and provision a brand new gateway control plane. And what we're going to do is we're going to go with the self-managed hybrid. And if you notice, there's also the Kubernetes Ingress controller option. We also have dedicated cloud and serverless. Now, you can pick any one of these options, but just for our workshop here, we're going to go with the self-managed hybrid. So I'm going to go back. I just need to check what name I'm going to use. But before I do, it seems like I might have missed a step here. We need an OpenAI key here, or an Open API or OpenAI API token. So I've got one. I mean, you might see this on screen, but guess what? It won't be valid after today. You might get lucky and you might be able to run a few prompts here and there, but after that, you are not going to be able to use it after today. And I'm okay with it because it's not like I've loaded a ton of credits on there or have it tied to my credit card and then, have to worry about a bill later on. So let me go find my key here. I actually had the key open a few days ago because I was doing some testing just to make sure that this all worked for us. So if you're working with OpenAI, you'll probably be sourcing your API token from the projects that you create. And all I'm going to do here is I'm going to run a sed command, which is going to go into a conf config that I have here in this root directory or this folder that I'm in right now, KGL 128. And it's going to effectively just replace all of those placeholders with my token. So I can definitely just do a cat against that kong.yam. I'll just verify quickly if it's there. And I think I saw something. Yep, it's there. So we're good to go. So let's go back to connect, because now we have to go and deploy our gateway, and we also have to give it a name. So here it says, we're going to proceed to select the self-managed hybrid gateway, which is this one right here. We're going to give it a name called KubeCon Kong AI because I'm at KubeCon, and obviously I want to celebrate that a little bit. By the way, if you're at KubeCon, please let me know. I'd love to meet up with you, and we could definitely have a conversation. Plus, we'll be at the Kong booth if you want to have a deeper conversation there. I would love to use 3.10, but we're going to use 3.9 right now. And that's just because 3.10 probably came out between the day I tested this and today, and I tested this on Sunday, and it must have shown up yesterday. So I don't want to risk it. I'm sure it'll work, but we're not gonna chance it right now. So as much as I'd love to use this particular configuration, I'm just going to make some slight modifications here. Actually, what I'm going to do is I'm going to change this to Linux because we're going to use the Linux setup. And that's because we're actually going to host the gateway in Docker right here in this environment. So I'm going to go back here, and there's a few things I need to just capture for a second. I need to capture this certificate and the associated key right below it. And I have to create some files here because we just want to make sure that we have our gateway version, because I actually do have a specific config file here that we're going to use. We're not going to use what's output there. And I just did this because I wanted to be a little bit more clearer here. So what we're going to do is we're going to echo what I just copied over here into cp.sir. And we're going to do the same thing for the key. So I'm just going to copy this element over here. And I'm going to do this same echo command where my key file is going to be. And we're just going to drop it into cp.key. Okay, so now what we're going to do is we're just going to make some slight modifications to our Docker compose file that we already have. And I'm in the EU. I'm closest to that region at the moment. because I'm in London. So I'm going to take advantage of what's here and make sure I modify my file accordingly. So I'm going to go into my editor here. I'm going to open up a file. I'm going to go into my home directory Ubuntu, and I'm going to go into the kgll-128 folder because that's where it is. And I'm going to go right to that docker compose.yaml. There's a number of things in this YAML file. I think the most important thing we want to be aware of is that Redis vector container. That Redis vector container is just our vector DB for this particular lab and workshop. And we are testing out things like Valkey and other vector DBs as well for the future. I think if you hit up the documentation, you can even see if some of them are already updated. So I'm going to go ahead and I'm going to just update these endpoints right here. The control plane, the server name, the telemetry endpoint, and the telemetry server name, just to point to this environment here that I've got set up. And the very last thing I'm going to do is I'm going to change my version to 3.9. I'm going to save that, and then I'm going to go back to my terminal. And I don't need to do any of these steps. I think I just need to come back here and clean this up. Let's just do a quick output of that Docker Compose just to make sure those elements have been changed. Ooh, found a mistake here. That could cause some issues. So let's go back to the editor. See, it's a good thing I checked. I missed that. Okay, saved. Let's go back to the terminal. Let's validate it again. Okay, so that looks better. If you notice, I've got the dot delimiter there for all 4 lines. So that separates my control plane ID from the region that I'm in to the actual function, the konghq.com on port 443. Okay, so that looks good. Now what we're going to do is, I think we have to, yeah, okay. We are going to go ahead and run docker compose up-d, which is simply going to turn on these containers. So it's going to take a couple of minutes. It's going to pull in these containers, and then trust me, once this is all good to go, maybe we might have to do a little bit of troubleshooting, but once this is all good to go, we'll be able to test out the AI gateway functionality. What's really cool is there's a deck file that I just showed you, the kong.yaml file, which actually lays out all the different plugin configurations. And I think we'll get to hit up a majority of them in this workshop, but I wanted to illustrate some of the key points and the key ones here so that you get familiar. So once this is done, what we want to do is we also want to be able to go grab our API token. Waiting for that Redis to be finished. Should almost be done. Okay. All right, so all of them are started. Now, if I go back here, there we go. Data plane found. Ooh, that took a little bit longer than I thought it was going to. But that's a good sign. So our data plane is created. It's available. It has no configuration on it other than who the control plane owner is, which is this one right now. We have to connect to this control plane. So what we're going to do is, you see how I click that connect to gateway? So I'm going to go here and I'm going to go to the admin API. And we're going to take this command here. I want to copy this command and have it on my terminal. So let me clear my screen. And if by the way, this is too small for you, let me know. I'll make it as big as I possibly can. But I'm going to go here and I'm going to go ahead and, oop, I didn't mean to do that. I'm going to go here. Let's go back to connect. Let's go to click that connect button. And then we're going to create an access token. So I'm going to create a new access token here. I had one called KubeCon. So you know what? We're going to call this KubeCon 4/1/2025 for today. And we'll just make this valid for like 7 days. Actually, there used to be a custom button here, but that's fine. So this token is only valid for 7 days. After 7 days, boom, it's useless. So next week, if you try to mess around with my my environment, good luck. That's not happening. So I've copied my token. I'll leave this open in case for whatever reason it doesn't copy. And this deck gateway ping command is simply just there to validate that we're connected to the gateway. I want you to also pay attention to this line right here because we need this one line. And it should ping. There we go. Okay. So we've successfully connected to the organization, which means our deck can hit up that control plane and we can pass in configuration. The next thing we have to do is we actually have to sync our gateway. So what we will probably need to do here is we can actually up arrow this because as much as I'd love to, do a lot of copy and paste, if I up arrow this, the only thing I need to change here is deck gateway sync. So it was pinged previously. Now I've changed it to sync, and I'm going to add the Kong.yaml configuration. And here we see all of the different plugins being created. Uh-oh. Something happened there. The advanced rate limiting didn't seem to update, so we may need to troubleshoot that, or I may need to offline. I didn't see that come up online previously. Let's just rerun this command and see if that works. That's fine. We can deal with that if we absolutely need to. So in the meantime, let's go ahead and check and see if our plugins were configured here. So if we go back to Gateway Manager and if we go over to the KubeCon Kong AI Gateway, we can see we've got a number of different plugins configured here. So if I take a look at my plugins now, you can see all the different plugins that have been created. Now, if I go ahead and click on, let's just say the AI Proxy Advanced Round Robin Weighted, or even the AI Proxy Advanced Round Robin, what we're really looking for here is that there are two targets effectively enabling us to go from our request or prompt over to any one of these different models here. And I think the model here in this case is, it should be somewhere here. GPT-4. So target 0 is GPT-4, and then target 1 is GPT 3.5. So if I go back to my window here, we're going to just test out some of this functionality around the advanced proxy, the semantic caching, and the prompt guard here. So let's go ahead and test out this advanced load balancing. I want to see if anything fails. Hopefully it doesn't. Okay, you see how this is completing? Okay, we're done. So let's go and review what happened here. So I'll go right back to the top where I ran that command. So what I did was a curl request for 10 iterations, and I sent it to my local host, which is effectively the Kong data plane running locally at the moment. And I'm going to take a look at the chat here. Oh, but I didn't use the 3.10 image. I used the 3.9 image. So control plane URL is wrong. Oh, no, no. Oh, yeah, I think you showed, I think I caught that, right? But I think we're good because my control plane and my gateway data plane are configured. The AI rate limiting advanced window size and limit now require an array of numbers. That's probably why I didn't want to pick 10, and maybe connect is a little bit updated, but that's okay. Now, if you look at this for a second, right, what am I asking the model? What is 1 plus 1? And the response I get is 1 plus 1 equals 2. But if you notice here, the model that responded for this particular query was GPT-4. Now I go down a little bit, right? That's GPT-4. That's GPT 3.5. So what's going on here is that my advanced load balancing capability is effectively just balancing between the two models right now. So I don't have to sit there and really do much other than know that if I send queries to one or if I send queries to my gateway or prompts to my gateway, it'll go to one or the other. And if we actually go back here, and if you notice this very last line even says what the weight is. So the weight is set to 100 at the moment. And quite honestly, at 100, and even for the second target at 100, basically it's a 1-for-1. So one request goes here, one request goes there. Okay, let's go test out the semantic routing. So in the semantic routing, we're going to direct specific requests to GPT-4. So this one should go specifically to GPT-4, while the other one would go to GPT 3.5. And all we're really doing here is demonstrating that my higher cost model should receive my more in-depth requests, while my lower cost model might not. And we know like GPT 3.5 is lower cost in comparison to GPT-4. So it'll take a second before the model returns a response, but the model will come back and say, Kong Inc. is a technology company that provides an open source API and service lifecycle management platform. Now, if I go here, something else I wanted to see if shows it. Okay, it doesn't show it here. That's fine. So we can validate that GPT-4 was the model that responded here. If you notice, I haven't specified a model in my curl request. And the reason why that is because if we go back and look, we can go back and look at the semantic routing models as well and the plugins and see how those were configured. If I go send this request, it says that George Lucas was the one who directed the first Star Wars movie, and GPT 3.5 was the one that responded to it. So if I go back to my plugins, and if I look at my AI proxy advanced, or let's see my AI proxy. One of these has it. I can't recall which one. AI proxy GPT-4, that's the one. And then AI proxy GPT 3.5. So we know that it's actually going to load balance to either one of these. Now let's look at the semantic caching capability. So remember, I was talking about how we cache our requests. Oh, there's a question here. Let me see what's in. What is the need of the AI gateway and what exactly it add onto the business? If you can explain it in short, that would be really great. So let me answer this live. The AI gateway itself is really a mechanism that you put in place to provide some governance within your organization. So you might have multiple models that you're consuming, and you're basically taking advantage of the Kong API gateway to route requests appropriately based off of a variety of conditions. So there might be certain conditions where I want to send requests one way to maybe a lower class model, where some of the more in-depth, more thought out, more reasoned style prompts and questions might go to an expensive model. Maybe I don't want to send customer data. Maybe I'm an organization that processes a lot of customer data, and I don't want to send personally identifiable information, any sort of PCI related information as well. I want to make sure that that's all sanitized beforehand. So we might analyze the request and then see, oh, wait, there's a credit card number in there. Let's remove that and then let the model process it without that information. Because why does the model need a credit card info? Why does it need it at all? It doesn't. So we can just remove it from the request path, and obfuscate that altogether. And that's where our governance comes from. We also need to consider the analytics piece of this. So a long time ago, this concept of shadow IT came about where I would just go to a cloud provider and swipe my credit card and boom, now I have an EC2 or GCP VM. And over time, accounting comes back to me and says, or comes back to my department head and says, wait a minute, for some reason your bills are higher this month. What's been going on? What are all these expense reports? And while that's one problem, the other problem is all of this AI has been consumed, or I should say compute has been consumed without awareness into the central teams that need to that generate compliance requirements for us on how we can consume these different models, which set security standards. So sometimes we might miss the fact that we might be sharing some of our own intellectual property with upstream providers without really knowing it. You know, in circumstances like that, that could be alarming and that could actually contribute to your competitors gaining access to that information as well. So the AI gateway, I mean, it wouldn't just be one. You'd be using multiples and different layers. It would come into this environment and effectively make sure your AI governance strategy is met and aligned. I hope that answers that question. And if not, you know, feel free to double down and ask me more, and I can definitely spend some time talking about it. All right, so we're going to test out semantic caching right now. And let's see what happens. So I've asked it to tell me what Indian restaurants exist in New York City. And it is taking a while. I didn't really specify a model, but I sent, oh, wait, did I? No, I didn't specify a model, but I got a response here. And there are a number of, I wish it outputted a little more cleanly, but there are a number of restaurants that recommended Indian Accent, Tamarind Tribeca, Ada, Pipali. There's a number of ones. Daba. Perfect. Right now I have an awesome list. Now, if I reword the context of my question, right, like quite honestly, it's not massively different, but it is different in the wording, and we're depending on the model to interpret that. We're also depending on the gateway, the AI gateway, to evaluate that and know that these requests are very similar. So let's go ahead and see what happens. And boom, it actually just literally responded within seconds. You know, the one thing that I wanted to show you here is in my request up here, notice how the set of headers that are sent are a lot larger. And let's take a look at a few other bits too, right? So where's the X cache hit? So the X cache status here is a miss. And what that implies is when I sent that request out to the gateway did an evaluation and noticed that there was nothing in cache. And because there was nothing in cache, well, okay, now I actually have to forward on that request to the model. But let me cache that request. And then once I get a response, let me cache that response as well. So you got a key value pair that now you can look up as you need to. If you also notice here, the XCONG upstream latency is about 11.6 seconds. I'm rounding up. And then the latency added by the Kong proxy is 0.871 seconds, so less than a second. But if I scroll down here and I asked it roughly a similar question, if you notice there's an Xcache key, which means it referred to a key inside of Redis, and then it returned a response in like 0.26 seconds or 206. Oh, actually, it should be less than that. I think the value here, yeah, it's actually 0.261 seconds, so 261 milliseconds. That's really quick. That's very quick, actually. And that becomes important because when you're thinking about how quickly your applications need to respond or provide responses, we basically need to make sure that your responses come back quickly. And not only does it cut back on the latency, especially for similar requests, it also additionally cuts back on your cost, meaning you're not consuming credits from your model anymore. So this call, even though I have an OpenAI API token that is in use at the moment, this second prompt that I sent over didn't cost me a penny. It didn't cost me anything actually, because it just pulled from, well, okay. In all fairness, sure, somewhere I'm paying for something in that, I have a system here that is running and it's consuming resources, and I have to host Redis somewhere, or I can use Redis as a server. But the overall savings is that you're not consuming that model cost itself. So there's a couple of others we can test out. The semantic prompt guard. So let's go and take a look at the plugin for a second, because I want to take a look and show you that semantic prompt guard and give you an idea of what we're really doing here. So it says only allow questions related to Kong, the API company. So if I ask questions about Kong, the API company, and I get a response back, I expect that it'll go through, right? If I ask, what is the um, what technologies does Kong offer? Or if I ask it like, what is the Kong Ingress about, or Kong Ingress controller about, I'll get a response back. But if I ask about like something completely unrelated, that request might be blocked altogether. So I want to change this up. I think I don't want to use this example. So let's look at this curl. And I'm going to change the content here. I don't want to know the history of Kong Inc. Tell me about Kong Ingress controller briefly. So it's going to take a few seconds. And boom. All right. So Kong Ingress controller is a Kubernetes Ingress controller that serves as an API gateway. It's a configuration management tool to handle complex routing, traffic management, authentication. I'm not going to read the entire thing. Now, if I scroll down here, this is funny. I'm not going to use this question, but I'm going to ask something else. So who is the director of Jurassic Park? Let's try who is the director of Star Wars? Blocked, 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 blocked. Now, effectively, that bad request is just an indication that my semantic prompt guard is working fashion, and it's telling me, hey, you're not allowed to ask about Star Wars, but you can ask about Kong all day long, and I'll send it up to the model. All right, so we have this advanced rate limiting function, and I'm actually curious if it will work or not. I actually want to go back and see what that error message mentioned to us. Actually, it seems like the error message is not there in the terminal anymore. We can try it out. If it doesn't work, then we could maybe attempt to troubleshoot it. But I'll show you what the rate limiting plugin looks like first. So if we go to the AI proxy, oh, the advanced rate limit wasn't configured, just the AI proxy rate limit. I need to review this and see what it did. We can try it out. If not, then that's a task for me to go out and finish it. And I gotta see what other available lessons are in here. We can go look at the SDK and streaming if this doesn't work for whatever reason. That's totally cool. Technically speaking, because of my API key here being consumer one, I should be rate limited, and it should stop functioning after a bit. No, it's not. Was that rate limited? No, it keeps going through, so the rate limiting isn't working. I wonder if it works for consumer 3 or consumer 2, I should say. No, it didn't get rate limited, so it seems like I need to go and take a look at that plugin. So how about this? We've got a bit of time. Let's just go and see something here. This is the Docker Compose. Let's go look at the Kong.yaml. I didn't really change anything here. And someone said something here. I can't remember what it was, but I don't think anything should have broke because of that. Well, you know what? That's okay. I'll need to come back and revisit this another time. Let's take a look at the SDK and streaming. So let's just assume for a second we are gonna just write the code in our systems, and I also need to check the time. Yeah, all right, we have a few more minutes left. All right, let's take a look at this SDK streaming. So I've got an application here. It's a simple Python application. And the key bit that I want you to pay attention to, actually, let me just cat the application. ls cat, I think it's appstreaming.py, okay, appstreaming.py. All right, so if we look at this, the only thing that's interesting about this one configuration here is that if you look at the client, we're using the OpenAI client, and the only thing I've done is specified the base URL to be the Kong gateway. So if you're looking at this from a developer standpoint, you will be consuming the OpenAI client or the Maestro client or the Claude Sonnet or whatever client that you need to consume. And the only consideration for this is, well, hold on a second. I only need to just add a single line here, which now just basically routes my request directly to the Kong gateway versus anything else. So if I were to do a Python 3 appstreaming.py, and I'm just asking it the same thing, this should return a response. And if you notice, it's also returning it in a streaming format. So if you're familiar with that format, it's like I'm asking it a question and it's just streaming it back to me like you would see in ChatGPT, for example. All right, so we saw a little bit of that. Let's go to the next, I think, oh yeah, the observability piece. So, while I've just showed you a bunch of different bits and pieces here within the terminal itself, you can go try this out for yourself. I also want to show you the analytics side of things. And if we go to the analytics here, and if I go to the Explorer, and if I go to AI LLM usage, and if I narrow this down to the last 1 hour, we can see how many requests we sent out to our LLMs. We can see the LLM latency. We can see the fetch the fetch latency is not there yet. We can see this latency, which is basically telling us like, how much time it took to go to the model and get a response back. So if we're also looking at token counts, and if we're trying to align this to a quota, we also get to see that capability as well. But the data is there. The data exists for us to be able to consume. And what's interesting is like, all right, let's just go back to the request count. If you're trying to enforce some governance, right, the analytics dashboard here gives you a lot of good details around what might be going wrong, maybe why a particular model is taking longer, and then the latency that's aligned to it. So all of that data gets imported directly into Connect. In fact, like I know Connect is taking some of this as well. There was a container in here. If you actually go play around with it, I believe it's a Grafana container that's in there as well. That Grafana container actually has similar details to really tell you like the cache latency versus like the cache miss latency and how long that request actually takes to get there. So I know we've got about 10 minutes left. There's a lot more that I can dig into here, but I'm going to stop for now and I'm going to let you all ask me some questions. So in the QA box here, let me go ahead and take a look and see what questions there are. All right, there's a question here. Analytics is available in OSS. So right now you can use the OSS gateway at the moment in 3.9, and you can actually take advantage of like the Grafana and Prometheus style analytics as well. The analytics that I showed you is specific to Connect and requires enterprise licensing or an enterprise agreement to be able to take advantage of that. There's another question here. Please briefly explain how the new AI RAG injector plugin works. So and there's a follow-on. Would be great if you participate in the discussion in support case. Okay. I don't know if I can participate in that discussion because I'm not too familiar with what the support case is. I'd actually need to go review that and see what the context is there. But the AI RAG injector plugin just allows you to tie into your RAG system. So uh, for those that are not aware of what RAG stands for, it's Retrieval Augmented Generation. What it's there to do is normally you would send a request to one model, but then to really check for accuracy, you don't like have any sort of mechanism in place to make sure that what response you get is accurate. And so RAG really helps with that, where you get a response, but that response isn't directly sent to you. It's sent to another model for additional validation, and it's cleaned up, and it's sent to another model for additional validation. And so the RAG injector itself is just to play on that to allow you to hook into your existing RAG systems at a high level. Now, how you've built out your RAG is going to influence how you consume that RAG plugin itself. Um, but for the support case specifically, I'm not too familiar with what's in it right now. And if it's specific to an enterprise environment, I don't think I can share that on screen at the moment, only because that might contain some enterprise confidential information for that particular end user. So I wouldn't want to showcase that to everyone. Um, I think we could follow up offline, Alexander. Feel free to reach out to me. My email is marino.widget@konghq.com, and then I can tie off with our support teams as necessary. So there's another question. Can I use the AI gateway services linked to other like chaining? Yes, if I'm understanding you correctly, I mean, the idea of chaining is effectively the usage of multiple plugins, if that's what you're going for. So you can set up an ordering of your plugins where one plugin is run and then another plugin is run. Here's a good example. You might be using the authentication plugin that basically removes the need for you to actually drop your key right into one of the other AI plugins. And then once that authentication has occurred, then it moves on to the next plugin, which is maybe your AI proxy or your AI proxy advanced, which is followed up with, let's say, a semantic cache, or that might happen beforehand. So you can use multiple plugins together in a single gateway instance for a set of services or for a single service or even a route. I hope that answers that question. And if not, feel free to expand a little bit more and I can answer that. And then the last question here is AI request transformer works for all LLM models. So we have a list of supported LLMs that's listed on our documentation site. We cover pretty much everyone. So even like Bedrock, Gemini, OpenAI, I'm just using in this particular example because it was probably one of the first to have really good SDKs and a lot of knowledge base that we could basically take advantage of. But Bedrock, Gemini, Cloud, as well as Mistral and some of the other ones as well. I I have to double check if DeepSeek is supported. I'm not entirely sure yet. But if you go to our doc site, you'll definitely find that out. Actually, I'm going to pull up the doc site for you and we can take a quick peek at that. Kong docs. AI gateway, and we can see for ourselves the different models that are supported. So if I share my screen again, all right, so we've got OpenAI, Cohere, Azure, Anthropic, Mistral, Llama 2, Vertex, Gemini, and Amazon Bedrock. These are the different models that are supported. I see that you have a question here. I have a problem with Llama 2, and you have a case raised with the support team. So if you, I mean, you could follow up with the support team as well. I'm sure that they can definitely provide some guidance as to what might be going on. It is extremely hard for me to be able to troubleshoot what might be going wrong with the integration that you're attempting to do today without having all the context. But if you're not able to progress further, I just shared my email. Feel free to send me a note, and I can probably try to poke the support team to see how we can get you a resolution. Are there any more questions? Dahlia, do you see anything in the chat?
Yeah, looking through it right now. Let's see. Yeah, let's check it out. Like, I think we have one, like the last one. Did you see it? AI rate limiting advanced. No, but that I think we went through it. Yeah, we went through that. So I think that's it. We went through that like 30 minutes. Yeah.
Perfect. All right. Well, I think that
any last questions? We have like literally 3 minutes to go, but if you want to ask one more, now is the time. Nope. All right then. Well, Marino, thank you so much. That was incredible. Thanks so much for answering all the questions. Thank you everyone for being here, for being so participative, asking all those questions. That's amazing. And yeah, for everyone that's joining KubeCon, enjoy. And Marino, good luck at KubeCon. I hope to see all of you at our next events. So keep an eye on our events page on konghq.com. And I hope you have a great day, great evening from wherever you're joining us, and see you soon. Bye.
Take care, everyone. Bye.